Hello students, today we are going to study Introduction of Channel Hydraulics. Now, the first topic is flow in open channels. Open channel flow involves the flow of a liquid in a channel or conduit that is not completely filled. There exists a free surface between the flowing fluid, usually water, and fluid above it, usually the atmosphere. The main driving force is the fluid weight. Gravity forces the fluid to flow downhill. Next is the unsteady, fully developed flow conditions. The component if the weight force in the direction of flow is balanced by the equal and opposite shear force between the fluid and the channel surface. The natural drainage of water through the numerous creek and river systems. The flow of rainwater in the gutters of our houses. The flow in canals, drainage ditches, sewers and gutters along roads. The flow of small rivulets and sheets of water across fields or parking lots. And the last one is the flow in the chutes of water rights. Now, some examples of open channel flow is shown here, that is the drop which is seen here. It is similar to a chute, but the change in elevation is affected in a short distance which is shown here. Now, next is the chute is a channel having steep slope which is shown here. Now, next is the open flow tunnel is a comparatively long covered channel used to carry water through a hill or any obstruction on the ground which is shown here. Now, next example is canal. Canal is usually a long and mild sloped channel built in the ground which is shown here, that is the canal. Next is the flume. Flume is a channel usually supported on or above the surfaces of the ground to carry water across a depression which is shown here. Next is the culvert. Culvert is a covered channel flowing partially full which is installed to drain water through highway and railroad embankments which is shown here, here and here also. Now, next is the comparison of open channel flow and pipe flow. Now, OCF must have a free surface. It means that the open channel flow must have a free surface. Now, in case of pipe flow, no free surface is present in case of pipe flow. Now, in open channel flow, a free surface is subject to atmospheric pressure, but in case of pipe flow, no direct atmospheric pressure, hydraulic pressure only. Now, in case of open channel flow, the driving force is mainly the component of gravity along the flow direction, and in case of pipe flow, the driving force is mainly the pressure force along the flow direction. Now, hydraulic gradient line is coincident with the free surface in case of open channel flow, but it is usually above the conduit in case of pipe flow. Flow area is determined by the geometry of the channel plus the level of free surface which is likely to change along the flow direction and width as well as time. Now, in case of pipe flow, flow area is fixed by the pipe dimensions. The cross section of a pipe is usually circular. Now, in case of open channel flow, the cross section may be of any from circular to irregular forms of natural streams which may change along the flow direction and as well as with time. But in case of pipe flow, the cross section of a pipe is usually circular. That is all about the introduction of channel hydraulics. Thank you very much, students.